Stars are massive, luminous spheres of plasma held together by their own gravity. They are born in vast clouds of gas and dust, known as nebulae, where they undergo nuclear fusion, producing light and heat. They are the building blocks of galaxies and the source of light and energy for countless worlds. Without stars, galaxies would not exist, and the universe would be a dark, cold place. The Sun, a rather ordinary star in the grand scheme of the cosmos, is the closest star to our planet, Earth. Despite its average size, it plays a crucial role in our solar system. Its immense energy output sustains life on our planet and illuminates our sky. The Sun's energy drives weather patterns, ocean currents, and even the growth of plants through photosynthesis. Understanding the nature of stars allows us to grasp the vastness and complexity of the universe we inhabit. Stars come in various sizes, colors, and temperatures, each type providing unique insights into the workings of the cosmos. Stars are not randomly scattered throughout space. They follow specific patterns and structures influenced by gravitational forces. They cluster together, bound by gravity, to form immense collections called galaxies. These galaxies can contain millions, billions, or even trillions of stars. Our own Milky Way galaxy, a spiral giant, contains hundreds of billions of stars, each with its own unique story to tell. From the smallest red dwarfs to the largest blue giants, every star contributes to the rich tapestry of the universe. Throughout human history, cultures around the world have gazed upon the stars with wonder and awe. Early civilizations connected the dots of the brightest stars, forming patterns and shapes that became ingrained in their mythology and storytelling. These patterns, known as constellations, are not actual physical groupings of stars, but rather arbitrary arrangements based on our perspective from Earth. Within constellations, smaller, more recognizable patterns emerged, called asterisms. The Big Dipper, for instance, is a prominent asterism within the larger constellation Ursa Major, the Great Bear. These celestial landmarks have served as navigational aids for centuries, guiding explorers and travelers across land and sea. Stars are not static entities. They are born, evolve, and eventually die. Their life stories begin within vast, cold clouds of gas and dust scattered throughout galaxies. These clouds, known as nebulae, are the stellar nurseries where stars first take shape. One spectacular example is the Orion Nebula, a vast stellar nursery located in the sword of the constellation Orion. Within these nebulae, disturbances, such as shockwaves from supernova explosions or the gravitational influence of passing stars, can trigger a chain reaction. These disturbances cause regions of the nebula to collapse under their own gravity. As the cloud collapses, it begins to spin faster and faster, and the material at its center heats up. This hot, dense core is called a protostar, the earliest stage in a star's life. The protostar continues to accrete material from the surrounding cloud, growing in mass and temperature. As its core temperature and pressure increase, nuclear fusion begins. Hydrogen atoms fuse together to form helium, releasing an immense amount of energy in the process. This energy release creates outward pressure that balances the inward pull of gravity. At this point, the protostar achieves hydrostatic equilibrium and becomes a true star. Its fate, however, is determined by its mass. The most massive stars live fast and die young, while smaller stars burn slowly and steadily for billions of years. Section 5. Stellar Adolescence, Tauri Stars. These fascinating celestial objects represent a critical phase in the life cycle of stars. Before settling into their long-lived main sequence phase, young stars undergo a period of instability and variability, known as the Tauri phase. This phase is marked by significant changes in brightness and activity. Named after the prototype star T Tauri, these stars are still contracting and accreting material from their surrounding disks. This process is crucial for their growth and development. They are characterized by strong stellar winds and intense magnetic activity. These winds can shape the surrounding environment and influence the formation of nearby celestial bodies. T Tauri stars are often surrounded by disks of gas and dust, the remnants of the cloud from which they formed. These disks are rich in the raw materials needed for planet formation. These disks are believed to be the birthplaces of planets, as gravity draws the dust and gas together to form larger and larger bodies. Over time, these bodies can coalesce into fully formed planets. Studying T Tauri stars provides valuable insights into the early stages of star and planet formation. By observing these young stars, scientists can better understand the processes that lead to the creation of solar systems like our own. Section 6. Cosmic Powerhouses, Main Sequence Stars. Once a star achieves hydrostatic equilibrium and begins fusing hydrogen into helium in its core, it enters the main sequence, the longest and most stable stage of its life. Our Sun is currently a main sequence star, about halfway through its 10 billion-year lifespan in this phase. Main sequence stars vary in size, temperature, and luminosity. The most massive main sequence stars are hot, bright, and blue-white in color. They burn through their nuclear fuel quickly and have relatively short lifespans of a few million years. Smaller stars, like our Sun, are cooler, dimmer, and yellow in color. They burn their fuel more slowly and can exist for billions of years. Section 7. Stellar Expansion, Red Giants and Supergiants. As a main sequence star ages, it gradually exhausts the hydrogen fuel in its core. With no more hydrogen to fuse, the core contracts and heats up. This heating causes the star's outer layers to expand significantly, transforming it into a red giant. Red giants are much larger and cooler than their main sequence counterparts. In the core of a red giant, helium fusion begins, producing heavier elements like carbon and oxygen. The star's outer layers continue to expand and cool, eventually becoming so tenuous that they drift off into space, forming a beautiful, expanding shell of gas called a planetary nebula. The core, now a white dwarf, is left behind. Section 8. Fading Embers, White Dwarfs and Neutron Stars. White dwarfs are the incredibly dense remnants of low and medium mass stars, like our Sun. These stars have exhausted their nuclear fuel and shed their outer layers, leaving behind a hot, dense core. They are about the size of Earth, but contain a mass comparable to that of the Sun. This means they have an incredibly high density, with a single teaspoon of white dwarf material weighing tons. With no more nuclear fuel to burn, white dwarfs slowly cool over billions of years, eventually fading away as black dwarfs. This cooling process is extremely slow, taking longer than the current age of the universe. Massive stars, on the other hand, meet a more dramatic end. These stars, much larger than our Sun, go through a different life cycle. When a massive star runs out of fuel, its core collapses rapidly, triggering a supernova explosion. This cataclysmic event releases an enormous amount of energy. This explosion is one of the most energetic events in the universe, outshining entire galaxies for a brief period. The light from a supernova can be seen across vast distances in space. The core of the star is compressed to incredible densities, forming either a neutron star or a black hole. Neutron stars are incredibly dense, with a mass greater than the Sun, but packed into a sphere only about 20 kilometers in diameter. Section 9. The Cosmic Abyss, Black Holes. Neutron stars are the incredibly dense remnants of massive stars. They are composed almost entirely of neutrons, subatomic particles with no electrical charge. Neutron stars are only about 20 kilometers in diameter, but can have a mass twice that of the Sun. If a star is massive enough, its core will collapse even further, creating a black hole. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are defined by their event horizon, a boundary beyond which escape is impossible. Black holes are still not fully understood, but they continue to fascinate and challenge our understanding of the universe. Section 10. Conclusion: the enduring legacy of stars. Stars are the fundamental building blocks of galaxies and the source of the chemical elements that make up everything we see around us. Their life cycles, from birth in stellar nurseries to their dramatic deaths, shape the evolution of galaxies and seed the cosmos with the essential ingredients for planets, life, and even ourselves. By studying stars, we gain a deeper understanding of the universe's grand design and our place within it.